In this lesson, we begin looking at arithmetic and geometric sequences. Suppose the set of a sub n from n equals k to infinity is a sequence if there is a number d so that a sub n plus 1 equals a sub n plus d for all n greater than or equal to k, then the set of a sub n from n equals k to infinity is an arithmetic sequence. The number d is called the common difference. For example, we have the arithmetic sequence -3, 1, 5, 9, etc. Note that we add 4 to go from one term to the next, and so this is an arithmetic sequence with a common difference of 4. The nth term for an arithmetic sequence, let's find the 11th term of this sequence, -3, 1, 5, 9. We already determined that the common difference here is 4. We add 4 to go from one term to the next. So if we want to go to the 11th term, how many times do we need to add 4? Well, to go from the first term to the fourth, we add 4 1, 2, 3 times. So to go from the first term to the 11th term, we'd need to take -3 plus add 4 10 times, which would give us the 11th term being equal to 37. Here's a formula for the nth term of an arithmetic sequence. A sub n equals a plus n minus 1 times d. Note that we're using a here instead of a sub 1 because a sub 1 is used so frequently, the first term in an arithmetic sequence. We just call it a from here on out. So if I want to use this formula for an arithmetic sequence for the sequence that we have here, and I want to find a formula for the nth term, I'll plug in -3 for my first term plus n minus 1 times 4 for the common difference, and so I will have a sub n equals -3 plus 4n minus 4, or a sub n equals 4n minus 7. And you will see that if we plugged in 11 for n here, we would get 37. Next, suppose the set of a sub n from n equals k to infinity is a sequence if there is a number r so that a sub n plus 1 equals r times a sub n for all n greater than or equal to k, then the set of a sub n from n equals k to infinity is a geometric sequence. The number r is called the common ratio. So in this example, we have 1, 1/2, 1/4, 1/8. This is a geometric sequence, and notice that as we go from each term to the next, we multiply by 1/2. So here the common ratio r is equal to 1/2. The nth term for a geometric sequence, for example, let's find the 8th term of the sequence, 1, 1/2, 1/4, 1/8. etc. And notice that as we go from the first term to the fourth term, we multiply by 1/2 3 times. So to find the 8th term, we will take 1 times 1/2 raised to the power 7, and that will give us an 8th term of 1 over 128. Okay, the formula for the nth term of a geometric sequence is a times r raised to the power n minus 1, where n is greater than or equal to 1. So if we want to find a formula for this sequence to find the nth term, we take our first term of 1 times our common ratio of 1/2 raised to the power n minus 1. So a sub n will be equal to 1/2 raised to the power n minus 1. Next, let's look at some sequences and determine if they're arithmetic, geometric, or neither. So for this first sequence, we have 1, 1/2, 1/3, 1/4. If we go from the first term to the second, and to determine if this is arithmetic, I would subtract 1/2. As I go from the second term to the third, I would subtract 1/6. So I can tell this is not arithmetic, because to be arithmetic, we would need to add or subtract the same number each time we go from one term to the next. What about geometric? Well, to go from 1 to 1/2, I multiply by 1/2. To go from 1/2 to 3, I would multiply by 2/3. So this is not geometric either, because I would need to multiply by the same number going from each term to the next. So this is neither. Next we have 1, -1, 1, -1, etc. So as we go from each term to the next here, notice that we can multiply by -1. So here we will have a common ratio of -1, and this would be a geometric series. Third, I have 1, -2, -5, -8, etc. So as I go from each term to the next, I'm going to subtract 3, and that works for all of these numbers. So I have a common difference here of -3. This would then be an arithmetic sequence. Try on your own. Determine if the following sequence is arithmetic, geometric, or neither. Explain your answer. 1, 0, 1, 0, etc.